Hello, Gator Scientist. Today we're going to do quiz corrections for Energy Quiz Week 3, Energy Forms and Energy Transformations. Question number 1 is a review of last week's quiz. What is energy? As I said last week, energy is the ability to do work, and that's just one of those definitions you just must need to do and know. Energy is the ability to do work. Without energy, we couldn't do work. Not scientific work, at least. Question number 2 says, Mary's class is learning about the conservation of energy. The teacher explains that energy cannot be created or destroyed, but it changes forms. It changes forms. Doesn't that sound familiar? Energy can neither be created nor destroyed. It just changes forms. Well, that's right. That is the law of conservation of energy. And we learned that rap, or the chant. Energy can neither be created nor destroyed. What? Energy can neither be created nor destroyed. What? Energy can neither be created nor destroyed. It just changes form. The teacher says that a good example of this is a light bulb. A light bulb. Then the teacher asked Mary to explain. What should Mary say is the reason that the light bulb is a good example of conservation of energy? Well, the light bulb receives electrical energy when she plugs in the cord. So it's electrical energy from the wires, and it turns it into heat and light. We call that an energy transformation. And that energy transformation could be written like this. A light bulb equals electrical transformed into heat, and the arrow means transformed into, and light. So a light bulb's energy transformation is electrical when you plug in the wire or the cord, transformed to heat whenever the light bulb gets hot, and then light when it lights up. Now we know that happens pretty instantaneously, but just so that you know, that is what an energy transformation looks like, and that's how you'll be seeing it in the future. Okay. What is the energy that's associated with the motion of the particles inside an object? Well, this is from last week's quiz again. Inside an object. Remember, we talked about heat being inside an object, and then we had that trick that we learned about thermal energy. Heat and thermal mean the same thing. They are synonyms of each other. And look, the word heat is inside the word thermal. Heat is called thermal, and chemical includes. If you remember the forms of energy song, you will see H-E-A-T, the word heat inside the word thermal. If you memorize your forms of energy song, which I believe is on week 1 and week 2's Weebly, you can listen to the song, and it goes to the tune of Frosty the Snowman. And one of the things it says is, heat is called thermal. So you can remember that heat is happening inside an object, like the beaker that was filled with water. And whenever the heat was higher, when the particles were moving faster. So the motion of the particles were going faster when it was heated up, really, really hot. But whenever you took the thermometer and turned it down really low, then the beaker of water froze, and the motion would have been hardly nothing. The next question says, which type of energy can only come from the sun and provides the earth with heat and light? Now, we've known from the last quiz that solar energy comes from the sun. Solar starts with an S, and sun starts with an S. So we can kind of remember it that way. A stone, number 5, a stone held above the ground has potential energy. When the stone is dropped, though, potential energy is converted to what kind of energy? So when I hold the stone above the ground and don't let it move, it has potential energy. But all of a sudden it gets so heavy I can hardly hold it anymore, and I drop it. The second that it starts to go into motion, that's kinetic energy. Motion is kinetic energy. Kinetic. That stone is energetic. This is a question that's a review as well. The energy that can be produced if in an electric circuit, if a bell, a buzzer, a radio, or a TV is added to it, is what? Well, if you look at light, heat, and chemical, those might all be part or one of these. If it had batteries, it might be chemical. Possibly the radio and the TV would have heat. Light might come from a TV, sometimes a radio. But sound is the only one that comes from the bell, the buzzer, the radio, and the TV. So it's just our best choice. Maya, number 7, is playing a guitar. Now notice, this question never said that it was an electrical guitar. If we ever want you to think of electrical energy, we'll give you the hint and say she's playing her electric bass guitar. So if you don't see the word electric, don't assume that it is an electric guitar. Guitars automatically are mechanical energy because you have to strum and move your hands across the strings to make them make a noise. So Maya is playing the guitar. She strums the strings and the guitar produces noise. Maya is transforming what kind of energy into what kind of energy? Well, we automatically know that noise is sound. So you can narrow it down to this answer or this answer automatically because sound is the second answer. But if you didn't know, remember it doesn't say electric guitar, so you automatically think of mechanical first. Now, had I put electrical guitar, then B would have been correct. But since it didn't say that, A is correct. Number 8 is just a review of the forms of energy from week 1 and week 2. The energy stored in the particles of matter, like a battery and food, is automatically chemical energy. I say battery, you say chemical. Battery. I say food, you say chemical. Food. You should be chanting after me, or at least saying it in your head. Number 9, the energy that comes from the movement of electrically charged particles. This is another review question. Electrically has the word electrical in it. Electrical energy and electrically charged particles go together. And it's the only best choice. That means that a wire is involved and that electrons are flowing through it. Number 10, this is another repeat question from the first week or from the week 2 quiz. The energy that an object has because of motion or position. Motion means that it is kinetic energy. And position means that that is potential energy. You can remember potential because position starts with a P and so does potential. And you can remember motion is kinetic, like that kid who's energetic. So mechanical energy is the mother, and her 2 twins are kinetic and potential. Kinetic means motion. Kinetic, a kid who's always in motion and energetic. And then potential is that couch potato. Number 11, Tyler stretches a rubber band so that it's tight in his hand. He has not let it go yet. The stretched rubber band has what kind of energy when he's stretching it back? It's sitting there like a couch potato. We haven't let it go yet. So it has potential energy. Potential. It's not moving. Number 12. Which of the following might a person use as a source of chemical energy? A sandwich, a light switch, water flowing in a river, or a bicycle? Well, if you remember a couple questions earlier, we learned that chemical energy is batteries and food. And the only bit of food here is a sandwich. A light switch, water flowing in a river, and a bicycle, none of those have anything to do with a battery or food. So a sandwich is just naturally the right choice. Number 13 says, using the flashlight above, the electrical energy is converted into light energy. We have to know that. That should have been a pretty easy one. Remember, how would you write that energy conversion? You would say flashlight equals electrical, and then dash dash, and then the greater than symbol, and it makes that little tiny arrow. Electrical to light. We could also say it would have heat, and some even make a sound. But our best answer here was light energy. But this is what the electrical to light to heat to sound conversion would look like for a flashlight. Number 14 says, Lucas plugs a lamp into the wall. The light bulb in the lamp turns on. What kind of energy transformation is this? Well, if Lucas plugged it into the wall, that automatically tells you that it had electrical energy because plugs and wires have electrical energy flowing through them. So you could have narrowed it down to A or to D because electrical is written here at the beginning of A as well. But these ones would not be right because electrical needed to be first. And then it says the light bulb, ding, ding, ding. The light bulb in the lamp turns on. Well, electrical energy is transformed into light and heat. Electrical energy is transformed into mechanical and heat. Now, if this said a fan turned on, you would pick this one because mechanical would be in a fan because it's motion making the blades move. But this said light, and so this is our only best answer because light was one of our choices. Number 15. This was a tricky one for some kids. Which of the following objects has the most mechanical kinetic energy? This means which one is the most kinetic. Remember, motion, kinetic, kinetic, a kid who's energetic. Is it a car going 60 miles an hour, a spring that's compressed or squeezed? We could automatically get rid of that one because that's not going to have any type of energy like we're looking for. A bicycle going 10 miles an hour? Maybe that one. A rock sitting on the edge of a cliff? No. This one would have potential, so I would get rid of that one automatically. We're not going to choose that. We're not going to choose this one that got squeezed because that just doesn't make sense. The only two that could possibly be correct are a bicycle going 10 miles an hour and a car going 60. Well, 60 miles an hour is way faster than 10 miles an hour, so this one, a car going 60 miles an hour, is our best answer choice. Number 16 says, heat energy is the same as a transfer of blank energy. Oh my word, remember? We learned a trick. What was it? Thermal. Heat is inside the word thermal. And since we can see heat inside thermal, H-E-A-T, we can get this answer right the next time. If you got it right this time, good job. But if you didn't, remember that heat energy is the same as thermal energy. Heat is called thermal. If you don't know that Forms of Energy song yet, you might want to go sing it. Remember, it's to the tune of Frosty the Snowman. Number 17 says, when coal is burned, Blank energy is being converted to blank energy. So this is an energy conversion. It's a transformation. When I burn coal, coal is a fossil fuel. Coal, oil, all of these were made from heat and pressure under the earth of dead plants and animal matter. So whenever all of those things would just die and they'd become like mulch, and then heat and pressure would squeeze it over time, it would turn into a fossil fuel. Coal is a fossil fuel. If I burn coal or if I burn oil, that's burning chemical energy. And chemical energy is then transformed to heat. So I burn oil in a furnace to transfer it into heat. I burn coal in a furnace to transform it into heat. Number 18 says that most of the energy that humans use on Earth originally came from. Who did everything originally come from? That's the hint. Originally came from the sun. Did you know that it takes 8 minutes for the light from the sun to reach our eyes? So that means 8 minutes ago, the sun was shining. And whenever we finally see it, it's 8 minutes later. It takes 8 minutes to travel the speed of light and to go 93 million miles. The sun is responsible for all of the heat on Earth, all of the light on Earth, and for us to sustain ourselves by plants growing, to keep us warm, and it also controls our weather. Question number 19. Jason ate a granola bar, and then he went for a run. He ran 1 mile and sweat heavily. Jason's body transformed chemical energy from the granola bar into what kind of energy? Well, if he ate a granola bar and then he went for a run and his body transformed chemical from the food into something else, well, it gave him mechanical energy of motion, kinetic. That Jason was energetic. And then, of course, anybody knows that if you run, you make a lot of heat. Question number 20. Study the diagram of the roller coaster above. Position A, way up here, is the starting point for the roller coaster. At which position will the first roller coaster car have the most kinetic energy? Well, if you remember, we had a graph that showed if you were way up here, your car's not moving yet and you have the most potential energy. So it only makes sense that if you went halfway down, you would have used up half of your potential energy, changing it into kinetic energy. So up here, you'd have 0 kinetic energy. And at point B, you'd have half of your kinetic energy, so 50%. So up here it's 0%, here it's 50%, and right when the car gets about here, it's at 100%, and then it levels out. So we learned on our little graph that was on our last Weebly from this past week, that it showed that right here at C would be where the kinetic energy was the greatest. And we would know that at point D, it had way less potential energy than point A, because point A, it has the most gravitational potential energy because gravity needs to pull it down further. But at point D, it's closer to the ground, so it has less gravitational potential energy. So, which one did it have the most kinetic energy? It was definitely position C, right here. Well, I hope you had a great quiz correction time, and Gator Scientist, I want you to be ready for next quiz. Thanks.